All right. So, lesson 1 for linear functions and their slope. So, we're coming off of just functions in general, but we're going to focus on linear functions and how that ties in with slope and writing equations. So, if we go back to last time, so here's our original function, 2x squared minus x plus 3, and we're going to simplify these expressions. So, first we're going to go through and we're just going to replace every x with an x plus h, then we're going to put it into the difference quotient. So, we would start with 2 parentheses x plus h squared, replacing this x squared, minus that x, so that's going to go to x plus h, and then plus 3. So, this first part, we would FOIL the x plus h squared and then distribute the 2 in. So we would end up with 2x squared plus 4xh plus 2h squared. So again, that comes from squaring the x plus h. So we have to FOIL that out, x plus h times x plus h, and then distributing this 2 in, that's out front. Here we're going to distribute the negative in and make this a negative x minus h, and then our plus 3. Okay. So that is our f of x plus h. Now I'm just going to continue on with this and do the difference quotient now. So we would subtract our original function, so minus 2x squared. We're minusing a negative x, so that's a plus x, and then minus 3. Okay. The whole thing's going to be put over h. So once we get to this part, the complicated stuff's done. Now we're just going to reduce. So the 2x squared and the minus 2x squared can cancel. The plus x, the minus x, the plus 3, and the minus 3. So the only thing we should have left are terms that have h's in them. And then we can go ahead and reduce one more h. So this h can cancel with this one. Reduce one of those and reduce this down to a 1. So we end up with 4x plus 2h minus 1. Now, get into slope. So slope formula. It's really just your change in y over the change in x. So in other words, your rise over your run. So y2 minus y1 over x2 minus x1. So subtract your y's over your x's subtracted. Make sure whichever point you start with, on top, you're going to do the same starting one on the bottom as well. So if we find this one's slope, we would do 4 minus, so the 4y here and the negative 1y, minus 1, over negative 2 minus our negative 3. Negatives become positive. 4 plus 1 equals 5 on top. Negative 2 and positive 3 is a positive 1. So our slope ends up being 5. Now, when we're talking about slope, we're always referring from left to right. So as we go from left to right, our graph is rising, is positive slope. As we go from left to right, our graph is going down. It's a negative slope. If it stays horizontal, so it doesn't go up or down as we go left to right, it's 0 slope. And undefined is when we're vertical. So we're going straight up and down, and there's no anything to the sides. So with that, now we can get into writing equations of lines. So we have our point slope form here, which is using the point x1, y1, and our slope m to come up with an equation. The x and the y stay the same. So we have a slope of 4 through the point negative 1, comma 3. So y minus the y of our point, which is 3, equaling our slope of 4 times x minus our negative 1, our x of our point, which minus the negative 1 makes it a plus 1. Now, if all it says is write an equation, this is an equation, we're good. However, a lot of times it's going to want you to write it in slope-intercept form, which we'll solve for y here. So first thing we would do is distribute the 4 in. So y minus 3 equals 4x plus 4. Add the 3 over. So y would equal 4x plus 7. And that's our slope-intercept form, which we'll talk about here in just a little bit. Now, what happens when we have 2 points and no slope? Well, we can find our slope. So first thing, m equals. Why they do m for slope, I'm not 100% sure. I'm sure you could Google that and find that. But I'm going to keep going on with the lesson. So, start with our y's. We have 6 minus a negative 3, which would make that a plus 3. On the bottom, we would have minus 2 minusing 4, or negative 2 minus 4. So 9 over negative 6, which we reduce down to a negative 3 halves. From there, point slope form. So y minus, I'm going to use the first one here. So plus 3 equaling negative 3 halves x minus 4. So I distribute this in. Y plus 3 would equal negative 3 halves x. The negatives would cancel to make that positive, and 4 cut in half would be 2, so 3 times 2 would be plus 6. So if we subtract the 3 over, you'll end up with y equals negative 3 halves x plus 3, okay, which is our slope-intercept form. Now, if we would have done the negative 2 and the 6, we would have gotten the same thing in the end. Still would have got the same equation, all right? Because we would have had a minus, so y minus 6, and then a plus 2 here. So we would have got a negative 3, and when we add the 6 over, we would have got the plus 3 too. Okay? So slope-intercept form. M, so the number what's in front of the x is our slope. So in this case, our slope is negative 3 halves. So we'd go down 3, right 2. What's added or subtracted on is your y-intercept. So being plus 3, we would start up 3 on our graph on our y-axis. If it was a negative 3, we would start down 3 on our y-axis. But we would use that when we go to graphing. So all of these functions that we're talking about are called linear functions because they're going to make a straight line since our x has an exponent of 1. There's not a bigger exponent, so it's just going to be a straight line. So when it comes to graphing these, we're going to start by plotting that y-intercept. So like I said, on this last one, we would start by plotting 3 on the y-axis. Then we're going to use our slope to find the second point. So we'd go down 3, right 2, and we put our second dot, and then we use a straight edge to draw through. And that is how we graph it. So if we graph this one, so we're going to start up 2. So on our y-axis here, remember this is your x, this is your y. So we'd go up 2. So 1, 2, and we make a dot. Then we're going to go down 3. So 1, 2, 3, and right 2, 1, 2, and we make another dot. Then, in this case, I have a straight edge handy, so I'm going to grab the straight edge, and I'm going to line it up, and I'm going to draw my line. And there's our line. So when it comes to horizontal lines, so where we get that flat straight across, we're going to use y equals b. B is representing any number on our graph. So say it's y equals 3. We would go up here to 3, and we'd draw our line across. If it's vertical, it's going to be in the form of x equals a. Again, a is going to be just a regular number, and it's going to be whatever x were involved. So if it's x equals 4, we'd come to the right 4, and we'd make a vertical line. Okay. General form of an equation of a line is ax plus by plus c equals 0. So everything's on one side, and we're set equal to 0. To graph this, we're going to find our x and y intercepts. So we could either convert it over to the slope intercept and solve for y, or it's easy enough just to go cover up your x and you'll solve for the y. That'll be your y intercept, and then you can plot that. And then if you cover up your y, you can solve for x, and that'll be your x intercept. You can plot that. You have your 2 points, then draw your line in between. Okay, so like for example, if I had 2x plus 3y minus 6 equals 0. So if I cover up my x, I'd add this 6 over, divide by 3, so y would equal 2. If I cover up my y, again, I'd add that 6 over, divide by 2, x would equal 3. So on my graph, I'd go to my y, up 2, put a dot. I'd go to my x, go right 3, put a dot. And then again, I'd draw my line, only use a straight edge, and it looks better than what I drew. So any questions here, let me know. Otherwise, until next time, we'll talk to you later.